a pump house needs to be placed along that river to connect two homesteads, 1A and B. If the pump house is situated at M, then we will have a pipe going to A and we'll need another pump going to B. The length of that pump may not be very economical. We might also decide that we'll move that pump house along that river anywhere along, maybe have it at X over here, and the pump line now will be from A to X and X to B. On the other hand, it may very well be that we might put the pump house right at N, and then we will have the pump line going all the way to N and up to B. So we want the shortest pump line. So how far should we point should the point X be from M so that the total length of the pump line is actually minimized? In this case, we need to find the distance AX, and we'll also need to find the distance XB. We don't know any angles except that this is a right angle and this is a right angle. So we're going to let MX be X. And therefore, XN can be 5 minus X, because we know that the total M to N is 5. Using Pythagoras' theorem, we just say that AX is the root of 2 squared plus x squared, which is just the root of 4 plus x squared. And now we can say that bx is the root of 1 squared plus 5 minus x squared, which will be just 1 plus, which is 26 minus 10x plus x squared. And total pipeline is just the addition of ax plus bx. And to find out how I can minimize this pipeline, I will have to rewrite this equation so that I can differentiate this. And differentiating this will mean that I'm going to have to use the chain rule twice. First for the first part, and then we'll do the same thing for the second part. And continue just to simplify all this. And once more. And to find when that pipe is going to be minimized, we'll need to make it equal to 0. So we'll just write down x into 4 plus x squared plus x minus 5 over all of that rooted. And that should be equal to 0. Okay, so it looks pretty ominous, but it's not. And there are two ways to go about it. First of all, we could look at them in sections, and see that we've got this part, we've got this part, we've got this, and we've got that part. So I want you to now pretend that what we have is we've got an A over B plus C over D, which is equal to 0. The two ways we can do this is this. We could do the butterfly effect and multiply together. So we'll multiply AD together plus CB together over BD, which means that we can now multiply the BD and the AD plus CB is equal to 0. We could do it like this. We could say that AB is equal to minus C over D. This way we won't have a common denominator, and we can just multiply the A and the D together and the minus C times B together, and we're really back again to the same answer as we were with the very first one. So I'm going to opt out to do the second part, not the first part, because then I don't have so much denominator work. This numerator over here can be written a lot better than that. And you know what? Denominators being a root looks really, really annoying. So I'm going to square that side and square that side. Because whatever I do to one side, I can do that to the other side. So this is already looks so much simpler. So now I'm going to cross multiply this together and continue with this. And I can see that that x to the 4 and that x to the 4 and that one and that can cross off, and I'll add these two together and I'll just get 100 minus 40x minus 3x squared, which is easier read in this manner here. So what we need to do is factorize this now into two parts. So x can be 10 on 3, or x can be 10. Out of those two answers, one of them is not possible, because if we go up back to our original drawing over here, which is which shows you that this distance cannot be bigger than 5. So x cannot be equal to 10. It's only 3 1/3. If we draw the sine diagram for this dp d theta and start at 3 1/3 here, we can have 0 and we go up to 5. We could insert any number between here, like 0, into our dp dw, and we would find that we will have a negative value here and a positive value over here. So this will indicate that this is a minimum point. And so for a minimum length pipeline, we will need to build the pump house 3 1/3 kilometers away from M.